So in this video, I'm going to show you integration by parts, but these are examples where you also have to use substitution. And I'm not going to lie, I think some of these examples have some kind of tricky, like creative substitution. So I've chosen these three examples and I'm going to break down everything for you in this video. So let's get to it. Okay, so let's start with the first example. So I think something that would be helpful is to explain like, why did I even choose to do something the way that I'm going to do it? So, okay. When I first look at this, my first inclination is to choose like 4x plus 1 for a u, and then my du, of course, would be 4dx. And it feels like this should be the way that this goes, right? So then I would have 1 over 4 du equals dx. And, okay, so then this becomes e to the square root of u, and then I would have this 1 over 4 du. Okay, so now you probably notice, like, I can't actually integrate that, right? So, like, okay, this doesn't work. So, all right, let's try again. So then maybe we think to ourselves, I'll clear some space. We think to ourselves, oh, okay, I'll just set my u equal to the whole thing, 4x, square root of 4x plus 1. And the thing about this is then I have to use the chain rule. So I'm going to get 1 over the square root of 4x plus 1 times 4 dx. This gives me an even worse problem, right? Now my integral is way too complicated. This is definitely not how the substitution is going to work. Okay, so now I'm going to tell you a very creative way to handle this, actually. So let me back up here. The first thing I think is that this really would be my ideal substitution. This is what I would really like it to be, because then this just becomes e to the u, and that I can definitely integrate. So this tells me that I would really like this to work out. So here's where we get creative. Let's say that this is my u. So what does that mean that u squared is? U squared will be 4x plus 1. Okay, so what if I decided to integrate this instead? Okay, so if I integrate this instead, so the left side becomes 2u du. So I just attach a du to indicate that I have integrated the left side with respect to u. The right side I will integrate as 4 dx, and I slap a dx on there to indicate I've differentiated with respect to x. So this is interesting. And our first thought might be, well, I can't go any farther with this. Now I have this 2u. This is all different. What am I going to do? Okay, here's where this gets a little slick. What I really need this to be is I need to just have dx by itself. So if I wanted to solve for dx and just divide by 4, so what would I have? I would have 1/2 u du equals dx. Okay, so here's my question. Is it actually a problem? Is it actually a problem for this to be in my problem? This has a u in it. It will just kind of change the nature of the problem, but I think this is okay. Okay, so let's just play with this here for a second, all right? So what I'm going to do now is I'm going to make these substitutions. So now I'm going to rewrite this as e to the u. Now, where I had a dx, I'm going to replace it with this whole crazy 1/2 u du. Okay, so let's clean up this. Let me clear some space. So to make this a much prettier looking integral, I'm going to rewrite this as u times e to the u du. Okay, so this is something that I can much more easily integrate than what I was starting with, right? So squaring actually helped, and it didn't change anything. It gave me a slightly more complicated like dx to input, but this is now an integral that I can solve. So now that I've actually done this, I'm like, okay, I can actually work with this. So now I've got to use integration by parts. Okay, now that I'm at this point, I'm like, maybe I should have chosen a different letter than u. Can I just change all the u's to y's? Let me do that. Okay, so I didn't think through my choice of u. I've switched everything to y so that I can now do my integration by parts. Oops, okay. So for my integration by parts, now my u will be y And my dv will be e to the y dy. That makes my v e to the y, and my du just dy. And this is totally going to work out now, right? So we had to be a little creative with the substitution, but now this whole thing is going to equal 1/2. So I take my uv, let's see, my uv is going to be y e to the y minus my v du. So actually this is just very simple now, so this is great. So now I can finish this. So this is 1/2 y e, oops, e to the y minus e to the y. Okay, and now I just have to replace all my y's. 1/2, let's see, this was, my y was equal to square root of 4x plus 1, e to the square root of 4x plus 1 minus e to the square root of 4x plus 1, all of that plus c. Oops, and this is also, I gotta have my 1/2 here, minus 1/2. Okay, there we go. That's everything. Okay, so kind of creative, right? But you can see how you might kind of get there. So sometimes being shown this trick and knowing this is a new thing you can do with substitution, now it's like you get a new superpower. Okay, so let's continue to explore our superpowers with substitution. So I've got x natural log of x squared dx. Okay, so this is another case. I mean, at first, like looking at this, you might think, oh, I could totally do integration by parts. But the thing is, so if I wanted to set my u equal to x, well, what would my dv have to be? Then it would have to be natural log of x squared. Not about that life. So we've got some work to do before we can start integration by parts. So what do we think that should be? Let's use y this time. Well, in this case, I feel like my y is probably going to be the natural log of x. So my dy then is going to be 1/x dx. Okay, so now I have to be really creative again. So I have to think about what things, like there's no way for me to rewrite y in terms of x. Like 1/x equals dy, so you know, it's not like I can write x equals 1/dy. So dy has to kind of stay on its own. It has to stay where it's at. We could add another y to the side, but it's not like we can have 1/dy. And dx is what we would like to solve for. Okay, so we can play around with this for a second. So I might think to myself, all right, well, dx would equal x dy. Okay, and the next thing that I can think about is like, how can I make this x off of this information here, all right? And so the only thing that kind of comes to mind now is maybe working with what facts I know about logarithms. Now, if you're stuck, so something I'd really encourage you to do when you get to this point in the problem, you're like, I have no idea what math there is to do. Before you look at the solution, think about just what properties they are. I would rather that you Google properties of this function, natural log, before you look at the solution, because this might spark a little creativity. So one thing that I think of is that there's this little property, e to the natural log of u. What does this equal? This just equals u. So this is a property in general, okay? So, so what if now I take this idea and I apply it here? Now here's where we're going to get pretty darn creative, all right? What I'm going to do is I'm going to take this and I'm going to raise each side, so e to each side. Okay, and this is pretty cool. So now, what does this side turn into? This just becomes e to the y equals x. Okay, and so now I can substitute that in there. So I know that's like super creative. And it's not something that you come up with overnight, but it's like you kind of just play around with this stuff until you arrive at, you know, this, oh, this actually works. So now I can rewrite dx equal to e to the y, let's see, I'll get rid of this, dy, right? From all of this work that we just did, using this property and then taking each side of this e to that side and then using, this property on this side, this is what has allowed me now to rewrite this thing. And so, okay, this is cool. Let me clear some space. And now I've isolated dx, which was really the thing that I needed to do. And now I can move forward with this. Now, the other thing is that this also allows me to figure out what to do with this x here, right? So we just had that property, right? E to the y equals x. So that works both here for dealing with this problem. That also works for right here. So let's rewrite this now. This becomes, so let's see, my x becomes e to the y. And then I've got my natural log squared, so that's going to become u squared. Oops, sorry, this is y squared. My bad. I'm so used to working with u. This is y squared. And then where I have dx, now I'm going to replace it with this little magic here. Okay, whew, craziness. So this becomes y squared e to the 2y dy. So now this is definitely an integral that I can solve. Right now I see where the integration by parts comes in. So let's make a little space. And now we can go ahead and use integration by parts. So in this case, I'm going to set my u equal to y squared. My dv is going to be equal to e to the 2y dy. That will make my v equal to 1 over 2 e to the 2y. And my du will equal 2y dy. So I'm going to have to integrate this twice. So let's see, this is going to give me uv, so let's see, this will be 1/2 y squared e to the 2y minus my v du. So let's see, when I do that, I have the 1/2 and the 2, those will cancel out. So this will just leave me with y e to the 2y dy. And now I can repeat the process. So now I can do my u is equal to y, my du is equal to 1 dy, my dv is equal to e to the 2y, and my v is equal to 1 over 2 e to the 2y. Oops, and I forgot my dy there. Okay, so making progress, right? So let's keep going with this. So I'll clear a little bit of space. Okay, so 1/2 y squared e to the 2y, and then let's see, I've got my uv, so that's 1/2 y e to the 2y minus my v du. So let's see, I'll bring out the 1/2 again, minus 1/2 v, so it's e to the 2y dy. Okay, and so now I can finish this 1/2 y squared e to the 2y minus 1/2 y e to the 2y plus 1/2, oops, this will be 1/4 e to the 2y plus c. And now you remember what y actually equaled? 1/2 natural log of x squared e to the 2 natural log of x minus 1/2 natural log of x e to the 2 natural log of x plus 1/4 e to natural log of x plus c. Are we having fun yet, fam? Now, we can actually take this a step farther. I'm sure that's what everybody wants to do. Let me clear a little space and I'll show you. Okay, so first things first, all of these natural logs can be rewritten with x squared. So let me do that first. So I'm going to rewrite this as the natural log of x squared. I'm going to rewrite this as the natural log of x squared. And then I'm going to rewrite this as the natural log of x squared. So why does that matter? So remember that little property I just told you, e to the natural log of x equals x. So what does e to the natural log of x squared equal? Well, that equals x squared. So I can actually simplify this quite a bit. So let me clear some space. Okay, and let me just write out what that looks like. So now I get this, so I've just replaced all those e's with x squareds. And so now I notice that I could technically factor out the x squareds. So I'll just show you what that looks like. So now I've taken the x squareds out. Okay, So the next part of this, if I wanted to go any further, is maybe the last thing I could really do is I could factor out the fractions. So if I factor out the fractions, so I get 1/4 x squared. So that will have to turn into 2 natural log of x squared minus 2 natural log of x plus 1 and then plus c. And that's as far as that goes. Now the last thing I want to state, this right here, natural log of x squared, this is different from the natural log of x squared. So this is squaring an entire natural log versus this is just squaring x squared. So in case you were wondering why didn't I do something with that, that is why. Okay, so that's as far as the answer goes. So that's it for that one. Okay, and one more. So I've got the cosine of the square root of x. So at this point, I would strongly recommend that you make a try at doing the substitution for this. I get that this is really hard, but if you try, and I would suggest trying like 2 different things and then like maybe trying to get a little help. So just make like 2 attempts at this. I've shown you a little bit of intuition, so I think you can totally do this. The worst thing that happens is that you don't get it right and then I show you part of the solution. But if you want to become a more creative thinker, and that's really what this is like involved, you've got to try a little bit and try to push the boundaries a little bit of your thinking and what you're allowed to do. So press play, give it a try 2 things at least, and then hit play when you're ready. Okay, so in this case, my u is going to be the square root of x. And so my du is going to be 1/2 times the square root of x dx. Okay, so that is not great. But what I think of when I look at this is I tried kind of a similar idea to the last one. So if I take 2 times the square root of x dx du, okay, so I just multiplied the reciprocal here, right? But check this out. What is the square root of x? That's actually just u. So I can now just replace this square root of x with u. And now, boom, baby, we're in. So I get very excited about this. All right, so let's go ahead now and let's do it. So this becomes cosine of u times 2u du. Bada bing, bada boom. So now we've got to use integration by parts, right? So let me go ahead and make some space. All right, so this one, at least the integration by parts is nice and straightforward. Oh, I did that thing again, didn't I? Darn it. Okay, let me change these all to y's. I will make these all y's for a moment. My bad. I've been recording for many hours today, so my brain is kind of getting to the limit of how much math I can do. Okay, so there's my u and my dv. My du is 1 dy. My v is sine y. Okay, so no problem. So my uv, so it's going to be y sine y minus v du. So that's minus sine y dy. So this is y sine y minus, let's see, plus cosine y plus c. And then I just replace what my y or my u, whatever you want to call it. So this is square root of x sine square root of x plus cosine square root of x plus c. Okay, so that is the end of that. If that was helpful, I would love it. It would be really great if you would hit the like button or subscribe to the channel. And I will talk to you guys in another video. That's it for me today.